Hello everyone, welcome to Service Provider Access Group. My name is Manish Mahajan. I am Technical Marketing Engineer for ME1200. This demo is about ME1200 remote management using a controller. We are calling ME1200 a touchless NIT because all operations on the NIT can be performed from ME3600 console, which is acting as a controller here. Key benefits of this approach are rapid deployment, management simplicity, and operational savings. There are two main components of this solution. First is zero-touch provisioning for initial discovery of NID in network. Zero-touch provisioning has three stages. First is management VLAN discovery using LLDP MET. Then IP address allocation using DHCP server. And once the NID has IP address, it can pull pre-configured configuration files from TFTP server. The other component of solution is controller, where ME3600 is acting as a controller to remote NIDs. All operation for a NID can be performed by sitting at ME3600 console. Communication between NID and controller is based on XML based configuration templates. Now I will show you how we can manage NID from ME3600 console. We are logged into ME3600 device, which is acting as a controller to remote NID. This command lists down all the NIDs configured on a controller. You can see there are two types of NID. First is dynamic and the other is static. Dynamic are the NID which are discovered during zero-touch provisioning process, and static are the one which are manually configured on the controller. Using this command, we can add a NID on the controller. Now you can see that we have a new NID with the logical interface ID 10. Every NID on controller has a unique logical interface ID. For the dynamic NIDs, we need an entire zero-touch provisioning process. As I mentioned, there are three stages. First is management VLAN discovery, and then DHCP base IP address allocation, and TFTP server. So for management VLAN discovery, we need this configuration on the ME3600 device. We need to enable LLDP, and under physical interface, which is connecting to NID, we need to enable LLDP MET network policy. And then using this command, we can assign management VLAN on the physical interface which is connecting to NID. So here I am using VLAN 21 as a management VLAN for the NID. The other component, DHCP server and TFTP server, I am using ME3600. So I will show you the configuration of a DHCP server on ME3600. So this is the configuration for DHCP server. You can see that pool for NID management IP addresses, and then we have option 60, which is a unique vendor class identifier. This string actually authenticates the NID. It has a ME1200 phrase followed by the MAC address of NID. Then option 43 is for assigning TFTP server IP address to NID, and option 67 points to the initial configuration file on TFTP server. Now I will show you how we will configure a NID from ME3600 console. So for that we need I'm going to edit NID 1. So all the operations which I performed under this interface will be applicable to NID 1 only. So you can see that this is the different category of operations which we can perform on NID device. It covers everything from provisioning EVC to provisioning all the basic parameters on the NID device. I will show modify and check the physical port on the remote NID device. So under this section we have different templates, like we have get templates to retrieve configuration from the NID. We have set templates to modify configuration on the NID, and show templates to check the current. So I am updating this template for physical port 4. After this, we have three options. We can review like what all commands are in queue. If we don't want to proceed, we can simply flush all the commands which we have previously enabled, and if we are okay, we want to proceed, we can give commit. So this was a show template. So need a response back with the current status of physical port 4. Now I will show you one more example how to configure a point-to-point service on NIT. Provision EVC section. Under this section we have all operations related to services on the NIT device. On the NIT, like for a point-to-point service, we have two components. First is EVC. EVC points to the NNI part, and second is EC. EC is for UNI mappings. EC stands for EVC control entity. So what I have done is I created simple CLI scripts. We can keep this as a CLI template for point-to-point service, and just by modifying the parameters, like for this I'm using service instance 108 and internal VID 108, and SVLAN ID is again 108. I have 5 as my NNI port, and I'm using default polyser 1. Similarly for EC ID 108, I'm using I'm mapping this EC to EVC 108, which I have configured here, and other parameters like tag pop count 1, I'm using the same polyser ID 1, which is default. My uni port is 4. I'm matching outer tag as a C tag, and it is specific. I'm matching a specific tag 107. I will make it 108, and then I'm matching PCP value 4. So what I will do is I will just copy and paste it on the controller. Similarly for EC. So once the operation is successful, need revert back with a success message. If there is any error in execution of this template, NIT will respond back with the error message. This EVC is configured or not. Now we can see that we have created a new EVC 108. We have EC 108 configured on the NIT device. So this was the example of how we can manage remote NIT from ME3600 console. We have another option where we can use a ME1200 local web interface to manage NIT. I will show you one example how we can run a RFC 2544 test from ME1200 web GUI. So under configuration section we have this RFC 254. First we need to configure profile. I have added one profile named demo. So you can say there is this is a form to edit the RFC 2544 profile. So I'm doing it on port 4 VLAN 20. We can select any MAC address and frame sizes which we want to test, and we can select the test cases which we want to run under this profile. I've selected throughput and latency, and then we can set the parameters for the selected test cases. We'll save it, and now we'll go to report section. From here we can run the test. So we'll start new test. So we have selected profile demo, and I will give the name demo 7, and I will run the test. You can see that it's showing executing. We'll go and quickly check the statistics of traffic on physical port 4. Yeah, we can see that there is input output traffic on physical port 4. We have on the remote device. This is a loopback with max swap, so it is sending back all the frames sent from ME1200. Now we'll go to report section. So you can see that showing the test is passed now, and from here we can generate a test report in a text format. So we'll go to save, and you can see that ME1200 generate the test report in a text format. The initial section covers the test profile configuration, what all tests we have selected, what parameters we have selected, and in the later section we have results of all the test cases. It covers the TX frames, RX frames, loss percentage, and for latency, like latency for different packet sizes. So everything is covered here. Yeah. So that's it from my side. Thank you very much.